status of the project, and have you guys written something? Because tomorrow I would expect each of the groups to have at least 1 or 2 pages of write-up for your work. When we say write-up, what is the format we do in that write-up? 1 and 2 page? IMRD, exactly. IMRD. Remember? IMRD is the one we follow. A modeling paper, maybe some general papers, because that paper discussion section, last paragraph, would give you evidence. Sorry, limitations in the study of the asthma. That will help you decide your research objective. Have you guys read some papers? Okay, so read it. There are so many papers. Even if one reads one paper, there are like 7-8 papers already done, which is a lot of information. And you don't have to read everything, you have to do quick reading, right? Okay, so I want in next 1 hour, research objective clear. So how do we do that? Each one of you find asthma paper, latest paper, like last 2-3 years. Look into their discussion, look into their last 2 paragraphs of the introduction, and figure it out what is the challenges in that area. Okay, each one can take a different paper so that you can have a time to discuss. And it should not take you more than 15 minutes for reading each paper. And then come back within a group and discuss. Each one of us talk about this thing, right? And whosoever agrees, I mean, if you all agree on one particular research question, use that as your main. It should be done by today in 1 hour. Okay, what about you guys? What happened? You guys were saying 2 people coming in? What happened? Okay, fine. Okay, so what is the research process?
इसमें IMRD की तरह काम कर रहे हैं, IMRD का सब है आपका। ये आपको अलग से
Remind me what was the topic actually. Okay.
And we just started
हाँ छोटा तो करना पड़ेगा आप बोले था टाइटल बहुत
So what is, okay, so I heard it, something to what is actually a goal? What is your challenge? What is you trying to do with that? I mean, we know the processed food is harmful to us, but we have to feed so many mouths also, right? We need processed food. Why do we need processed food? Because it has more shelf life. It can last many days, it will not expire, right, so fast. Also, you can, it can, transportation issues, it doesn't mean freezing sometimes, fresh food might be. So those are the benefits of processed food. It is not used just because of the economic reason, it is used also to feed so many mouths. So,
specific
don't always think about it is a bad thing. If you have a prior notion of it is a bad thing and I want to only study health impact, so think about the question that it is a trade-off between good and bad. Everything is good and bad. So what is your question? Okay. So I think I want you guys to read a little bit more. 4 of you are there.
ब्रॉड निकलता अच्छा ओके
किस बेसिस पे एडमिशन साइंस स्ट्रीम या फिर
ये इतना नहीं आप मैं समझ गए वो सर समझ जाए आप
बेसिस पे कि स्ट्रीम साइंस साइंस स्ट्रीम एडमिशन
फोन देने में नहीं मिला इसमें है इसमें
स्ट्रीम कहाँ से चेंज होती है
Yeah, well, the thing, first of all, I didn't understand your logic about 3 or 4 plus mathematics. I didn't understand what is the logic. Research is not about this at all. Research is cross-disciplinary. Because the research, I have done research with social scientists, I have done research with medical practitioners, cardiologists. They don't understand any equation. That's the best way, because some of the skills we as a mathematician might have, some people, some of the skills they will have. And research needs complementary skills many times, many different. So what are, and again, push yourself to what the size of the course is. Be free on choosing what is best for you. And you will see you are funneling down in a way that will lead to a eventual position as first of all, I like it would be more than sufficient, right? And you put everyone's name there and make it as if you are doing a research presentation, right? With your background information, with your research objective and your plan of study. Now it will not be perfect, but at least you should get some idea about it. And tomorrow I will also going to talk about how we will continue to work on this thing remotely after we leave here. And we will set up a time accordingly, and I will try to also join most of the group. Okay, so that's the plan. So what we will do is, let's open our laptop and our studio, and we will work on some file. And go to that shared folder in the classroom, Google Classroom, and download some of the files that I have posted it there on a day 3. Day 3.
हाँ पापा
आदमी नहीं काम
You guys have a folder, so and the R studio is on, right? So now what we do, okay, let me connect that. What object is not formed? The file is not formed, or it is what is not formed? What? Why is it they are having error? No package. Which package? So D solve. So then So so look at here. If it is saying D solve package is not formed, remove this hash. Remove this hash. So there was in this line number 10 line, there was a hash mark. Hash is comments. Comments, they are not running, right? So I removed the hash from this line and rerun the top 12 lines. Rerun it. How do you run it? Again, same way. You select the top 3 and then you press run. It will ask you to update the package. So you said yes. Or upload it. It asks you. Yeah. Successfully done. And the code has no error now. And the code has no error. Yes? Yeah? Code error. Where is the folder? Yeah, install. Press install.
Okay.
Oh, it is still installed. Let it do that. Okay, now run. Yeah, so show me the folder where all the files are. The download? Put them in a separate folder. Make a new folder and put all the files in. How about you guys? Working? Huh? Huh? Okay. Now, if you are done with that, go every 2 lines, select it, and press run, and try to understand what is these every 2 line doing. What is first 12 line doing? What is first 12 line doing? What is this 12 line doing? What is? Huh?
Install package.
So it is installing a package. Dsolve is for solving a differential equations. So that is dsolve package, which is already there. And second thing what it is doing is sr function.r. You have to write equation of SIR model. ds by dt equal to this, di by dt equal to this, dr by dt equal to this, which is in this function file called SIR function. It's in the folder. It's there already in the folder. So you can click and open that file. Click sirfunctions.org, right? And do you see SIR equation or simulate SIR or something like that? Look at this one. This is in the file sirfunction.r. This is the differential equation. Can you see that? SIR model. ds by dt equal to minus beta si over n. This is the differential equation. There are other functions also which we will understand later on. Right now this is important function. Okay. Let's go to back to the same file. So we are back now to SIR real data.r. So select the next 2 line, 14 and 15, and run. What is the next 2 lines doing? Were you guys able to get, or is it distributing error? Huh?
कहाँ जा रहे हैं ये इसमें जा रहे हैं कहाँ जा रहे हैं
Now, with the session. Okay, so that is the problem. Where is the data? Where is the file? Desktop? There is no file. Is there? Okay, go back.
दो बार डाउनलोड हो गया मेरा लैपटॉप में गया
It's a desktop or is somewhere else? Open. Here is, can I have your attention, guys? So, is it working or not working? Yeah, everyone was able to run the file R, I mean the SCIR real data, this file, and I think Ashwini pointed it very well that the data file has a different name. So you have to change it to, this is the data file. You have to change the name of the data file so that it is same. When you download, it has a different name. So just change it to outbreakdata.cs2. Okay. So what is this doing? Who can tell me what is this doing? What is this line doing? This is very important line. This particular, the selected line. So what is source means? Source means, source is an inbuilt function in R. It compiles all the things in that file. So if you see, it is running the SIR function file. So let's look at the SIR function files first. So SIR function files has many functions. Function 1 is here, which is estimate growth rate. Function 2 is here, which is SIR params from lambda. There is another SIR OD function. There is simulate SIR. There are many functions in this file. And the purpose of the functions are separate, individual functions. The task is very different for each function, right? So what we are doing actually is we are writing all the functions in one file just for the neat and clean your main file, because otherwise there will be too much information in the main file, right? And this file is called into the other file by a function called as source. Is that okay? So when you run, I'll go back to this file now. So when you run this line number 12, you start seeing all the function which is in the function SIR function file. These are all the functions. Can you see that on this side? Right? So I've ran up to 12. And then I've ran this 2 lines which is reading the data. It is reading the data and bringing the data here. Where is the data? Data is stored in DF, because DF is the name that I have given for the data. So it's in here. So it says there are 15 observations consist of 2 variables. It looks like this. 15 observations, if you keep going, 15, and 2 variables, day and reported cases. That's the data. Okay. So I'll go back to this file. Okay, next is, this is actually not too much important, but this is a check, basically for an error. I will skip this thing right now, just run it. And don't worry about what exactly it is. So just run it. After running, you come here, explore. When you explore, what do? You plot this data. basically this data consists of initial outbreak. So it is taking 1 to 15 days of an outbreak, initial days. Think about it as a real data of a certain outbreak, any outbreak. It's actually a made up data, but it is similar to the real data. But it is showing first 15 days of the data. So, okay, so let's see the plot of the first 15 days look like what? I ran it. This is the plot of the first 15 days of the data look like. So it is saying first 15 days how much count of cases are there for a particular disease. Is that okay? Next what we do is, we do one thing like this. What type of scatter plot does this look like? What type of shape is this? Looks like an exponential. Looks like approximately exponential, right? Exponential growth. If I take a logarithmic of exponential function, what is the function you get? Linear function. As soon as you take log of exponential function, you get a line. And that's what is the next two lines doing. So, if you take a log of that, it gives you approximately line. Again, it was approximately exponential, so therefore you are not getting exact line. It's an approximate line. Okay. Which is better to fit? Non-linear function or a line? Line. And therefore this is important here. So we are converting the real data into logarithmic functions so that we can fit a line to it rather than an exponential function. Okay, we could have done, it's a simple exercise, we could have done either one, but in a complex case it will be better to fit a line rather than a exponential functions. Okay, so next is we estimate this function, estimate the lambda or the growth rate of an exponential function. So what it is doing is, now it is fitting, so let's run this code first. Run this next line code and it gives you the lambda hat. What does the lambda hat look like? Can you find lambda hat? It's here. Yeah, something like this. This is lambda hat. This is lambda hat. It is done by this estimate growth rate. Right? Let's go in the SIR function and see what is this function doing. Let's just go to this function file and look for estimate growth rate. Where is that? Here. Right? And what is this function doing? Can you guys read? It's a plain English. It is taking a log of the data and then it is basically fitting. Where is it fitting? Where is the line for fit? LM. This is LM is linear model is an inbuilt function in R. So it fits the line at this line, number 11. Number 11, it fits it and gives it, what does fit mean? It gives you slope and intercept of the line. Does that make sense? Right? Okay or not okay? Yeah? Okay. So, this is the function and it ends here and it spits out the values lambda hat, which is what we are seeing it in the other file. So then it goes here and then it plots the graph. Let's see the graph now. Now note one thing, it is the log fitting, so it is a linear fit, line, right? That's why it is used LM, linear regression. You see, it fits the data with a line now, right? So that's just plotting with that lambda that you have obtained from the other file. Okay. So now what do? You have find the lambda value, which is exponential growth, right, of the curve. Now remember that R0, remember I showed you the formula of R0 with the lambda in it, 1 plus lambda, right? So then what it does is, it takes the because it was lambda over gamma, right? The gamma was taking in infectious period, right? Gamma was an infectious period. So if the infectious period days are duration in which person remains infectious period is 5 days, then basically this SIR params from lambda, so it is converting and computing R naught. So what is the function name? SR params lambda, right? So the goal here is from lambda, what was lambda? Lambda was the growth rate, right, of the curve, of the data. From the lambda we are computing R naught. R naught was what? Reproduction number of the SIR model. And the formula was what? R0 equal to 1 plus lambda over gamma. If you remember, lambda over gamma, right? We are using the same formula in this function. So let's go to SIR param from lambda. Where is this function? This is this function. You see, look at this. It is calculating, where is the lambda? Here. Remember that beta was lambda plus gamma? Yeah. So it is computing beta first and then computing R naught using that same formula that we talked yesterday. And then it is spitting out beta, gamma, R naught in the main file. It's just throwing back the estimates of it. Okay, so then you go there and you just plot all of these things. So let's plot it. And it spits out beta. So using the lambda, first you computed lambda, then you computed beta, then you computed R naught, and then you computed basically R naught is the last one right now. So it comes out to be 2.25. That means there is an outbreak. R naught is greater than 1, so disease will grow, right? And it will not decline. Okay. Then once I have beta, see, we don't have a beta estimate because it's very difficult to get it. So we are indirectly estimating beta, right? Once you have the beta, then you run simulation, simple simulation, which is done by this function simulate SIR. And you go in this simulate SIR. So this is SIR OD, which is differential equations. And then simulate SIR is what simulating it. Okay, it's very simple. It's using an inbuilt function DE solve, and it is taking SIR OD where the equations are written. It is taking all the parameters that you just estimated, right? You estimated the parameters and then spitting out the solution out. So coming back to there, so there is a sim base is where the solutions of the SIR model for that estimate of beta that you just found. Does that make sense? And then you simulate it. So let me show you what the simulation look like. Say it again. Any question?
In this code, sim base.
Okay, something is wrong.
N is equal to N.
I'm sorry?
N is equal to N. That is error.
This N? Yeah. This is the population size. We are taking a population size. Total population size is 10 to the power 6. That is the assumption. But you can change these values. I mean, these are hypothetical situations, but you can change some of these things. So let's run one by one. There's something I have not ran, so let me where was that? Yeah, let's run it in this one. Oh, it is installing the package somehow. Yeah, so it should run actually. Now it is in the middle of stalling. So you're getting this plot. So he's getting the plot here. He's getting this plot here. Are you guys getting this plot on this side? Yeah. So it is correct. Now you have estimated the parameter and you have calculated R0, and you have now plotted, you have fitted the model to the initial outbreak. So your model is good for prediction because initial outbreak was only 15 days. Now you can extend it beyond 15 days. How many days is this? 100 days. Almost 100 days you are predicting after 15 days using this model. Right? Does that make sense? Okay. And you continue like this and what happened? Yeah. I have not plotted it actually. Yeah, so this is the simulation, right? Okay, next is interventions. You can do the same thing. I think we are 6:30. Sorry, my apologies. It is past 6. You can do the interventions of different sort. Intervention. What does intervention do? Intervention changes the contact rate. For example, you put a quarantine. What does it change? Beta. It changes the value of beta and want to see what happens eventually for 100 days. And that is what it is doing. So play with this thing. If you have questions, let's talk next time. But you understand now how these different files works with each other. Okay. Thank you very much. Have a wonderful evening. See you tomorrow.